Right, good afternoon, Amsterdam. Yeah, so for those who didn't put their headsets on, now's the time. Ready to dive in for half an hour about security and DevOps? Thumbs up if you can hear me. All right, good. The fifth element, who's seen the movie? Raise your hands. All right, so you know what it is about. It's about a fifth element being centered by the four elements of life. The protector of the universe, the protector of all life. Well, the thing is, and sorry for pacing up because I only have 25 minutes, and normally I take this session about 4 hours, so we're in for a ride, right? The thing is, with that movie, the protector of life is the center point about four elements of life, and we can actually see the same in development and having security fixed all over the place. So from a developer point of view, from coding to the end until you deploy your solution. And that's what I'm going to talk to you about, and that's the link with the fifth element. So bear with me. I'm Mike Martin. I'm what they call a cloud solution architect at Microsoft. I work for the Belgian sub. I'm Belgian, and I'm sorry for that, for those who know me. If you want to contact me, there's a QR code on Twitter, and there's also my email address. You can ask me questions later. I will not answer anyway, so that's a good thing. All right, so let's talk about December 2020. Everybody here ever heard about SolarWinds? Raise your hand if you have. All right, so SolarWinds is a nice company that has a nice monitoring tool that they build up that they can deploy at any kind of customer. Now, something happened in December 2020. They got to be the how should I put it, the opening and the catalyst for ransomware attacks all over the world. And the reason why is because somebody got hand off their development environment, got injected some malicious code, and they were able to do a drive-by shooting while running the software of SolarWinds. That's exactly what happened. And this is what we call a supply chain attack, a software supply chain attack. And how does that work? Typically, we address somebody like phishing, we get some access into the system, and then we start hovering around and doing some lateral movement until we reach something that we can use, right? And in this case, it was something called TeamCity. And TeamCity is a very well-known CI system from JetBrains, which was not the culprit as such, but it was used to get access to the resources where the source code was being hosted. What they did is they just injected, and I know it's a little bit small, but as you can see, the only thing that the malicious culprits did was injected this little set of code. It's like what? 1, 2, 3, 4, 6 lines of code. They even did a try-catch expression. So they actually tried to do some error logging on that and doing the good job. But what they did, they just added an additional DLL and gained access to the rest of the system, but then afterwards using command control systems to download the real code that would do the ransomware and blocking all the systems. Is this clear so far? All right. If I'm going too fast, I'm sorry. So the thing is that you need to protect end-to-end because the developer didn't know that he had full admin access on the TeamCity where they can actually move on from and then go into the resources. And then from there it got deployed all over the world. So what I want to talk to you about is about the protection in these 5 elements, in these 4 elements with the adding of security as a 5th element, right? We talk about secure design. We move over to secure coding, and then from there out we take it into the secure building part, and then into the secure deployment, and actually the constant feedback loop that you have from a system point of view. And for that we target the SDL best practices. So the software development lifecycle best practices for security in this case, the SDLC. And what most important here is that you actually are looking into making sure that people are well prepared, that they know what they're doing. And as a developer, you know it's very needed that you know exactly how threat safe that you're coding, but also that you need to know how well that you code against security principles, right? Inclusion of the other parts that are very important, like security testing, right? I work for Microsoft. We have a lot of tools that can complement you, from free to paying, unfortunately, but at least you can get there in a secure way. And that's exactly what I want you to think about and exactly what I want you to take away with you after my session. Now, for those who have been here in one of the previous sessions, there was a guy from SNCC who was doing a lot of demos and a lot of cool stuff. His things are just as valid as any other. It's actually a very cool tool. Also take a look at those. Right? And in the end, if we take a look at all these 12 components, it's also important that we have all the right processes in place. So the first thing that we should think about is driving zero trust principles. We should all drive from a zero trust point of view. Never go beyond having more privileges than you need. You use least privilege access and verify explicitly. And that's why all developers should actually use this a little bit more. Use your phone more. Activate multi-factor authentication onto your systems, on any kind of system that you have, whether it's your source code, whether it's your Active Directory, whether it's your endpoint where you're going to deploy on. Make sure that you activate a secondary security feature. The last part is also very important. Never assume that you're safe. Always assume breach. If you're getting from there, you are already like 50% grown into a secure mindset. So that's on the zero trust principles that you can take away with you. And as I said, it's really about, it's really about multi-factor authentication. And for those who see in the movie, at a certain point in time, Lilo Dallas goes like, multipass. That's actually a multi-factor authentication that she's using. Lilo Dallas multipass. So use it at your convenience. We provide, as Microsoft, log in into Azure DevOps and GitHub, and you can even use Azure Active Directory to securely log into those systems. Multi-factor authentication comes out of the box with Authenticator. If you want to use something else, fine by me, but at least make sure that your system integrators and your system managers know what to do there. Let's step over to the secure design. The secure design part is actually starting from the part where you're analyzing the software requirements and the system requirements. The first thing that you need to do is start implementing something called Stride, making sure that you can identify all the risks and actually identify all the threats. And this is a concept called threat modeling. And threat modeling you can do by using this acronym where you can actually take a look at these 6 elements, spoofing, tampering. You can read them for yourself, where you can actually score against and say, what is the mitigation, what is the risk that my system is actually going to have when I'm doing these. We have a scoring mechanism for that too, against that Stride mechanism. They're called DREAD, but I'll leave that for the next part. But the most important part is, what is threat modeling as such? First of all, it's what are you building? And then you should ask yourself, what could possibly go wrong? And this is the identification. What could possibly go wrong? And we all know that as a developer, nothing can go wrong because it always works. We're good developers, we know what we're doing. Right, said no developer ever. And the last most important step in that cycle is make sure that you can identify the mitigations against those risks, against those threats. And that's the most important part. And of course, validate, but that's just the current flow of the cycle of the process. Most important is that you do this in a recurrent state, that you always keep doing that. And you don't have to really start from the beginning of a greenfield application. You can do this center stage also with already a brownfield, already something that you have as a legacy tool. Now, Microsoft has a free tool for that. It's called TMT, not your Teenage Mutant Ninja Turtles, but threat modeling tool. It's a free download with click once, and it can install only on Windows. Unfortunately, there's other free source tools for Linux and Mac too. But this one is really cool because it actually gives you the capability of using some templates, as you can see there, drawing them on a canvas like Visio, connecting the dots. And the cool thing about this thing is it will generate a report, and I have one open here, because I need to have at least a few demos. It will generate you this kind of a setup, and it will generate you a report in the end. If I'm taking the correct, where is my, here it is. It can generate you a full report with the entire structure of the application as you draw it out. Unfortunately, I cannot see my mouse. Let me see. Nope. Come on. All right, let's do this again. One more time. Allez. Come on. And you get all these little components separated by yourself, including all the stride elements that you have. So elevation of privilege, you have a denial of service. All these stride elements will be generated for you because all of these components that we drew on the template actually have the properties to set right by means of the connection that they have with all the different services in between. So this is what you can use at least as an identification of all the risks that you have in your software. There's templates for AWS, there's templates for Azure, there's templates for certain Microsoft systems, there's templates for certain verticals, so check it out just by going to those links. Now it doesn't have to stop there, of course, because you also need to make sure that your dev environment is secure. The dev environment is mainly RPC, but what if you want to have a secure environment set up by the processes that your organization needs to support? For this, we can support you with things like code spaces, where you have a VS Code into the browser that can be actually managed through the dev containers that are lying behind, and that can be fully managed inside of your organization with all the best practices for secure development in place. If you feel that you need more like Windows tooling or more advanced tooling than Visual Studio Code Spaces, you can actually use DevBox, where you can install fully fledged Visual Studios, IntelliJ's, WebStorm, PHP Storm, whatever IDE that you want, and actually brand them and narrow them down in the scope of the secure developer. That's basically what you can do with DevBox. It gives you a nice flexible portal where the developer can actually select the device that they need, and that way they don't need to have unsafe practices on their development machines without any compromise for the organization. Now, it doesn't stop with the secure environment of the developer. You also need to make sure that the developer is aware of all the risks that there are. Make them aware of things like SANS. Make them aware of things like OWASP. OWASP has a top 10 with all the weaknesses per kind of application level. Today we have them for OWASP for the web, but we also have them for API, for instance. Make sure that your developers know all these weaknesses, that they know about SQL injection, that they know about cross-site scripting, that they know about all these things that can make their system weak. So nobody can actually just do injection or forgery or all these things. I have more reading for that. I will make sure that you get the slides somehow. I'll leave that for your reading. Then make also sure that if you're doing development, that you do key management. You don't want to set secrets inside anything like a web.config or whatever. You want to make sure that an authenticated user is getting those keys and just injecting them back into the use case that they have in their session, and that nobody else can access them in any other means. So no web API keys embedded into your code, no hash keys for storage accounts, for instance, where you have your appreciate keys. You want to make sure that you put them in something like a key vault or an alternative like that, like an HMS, right? And then from there out, you can actually use key configurations in ASP, Blazor, whatever JavaScript tooling. There's SDKs for these things where you can just address these in a secure way. If you do, however, make it happen that you inject secrets into your code, well, bad luck. But as Microsoft, we had a little tool a couple of years ago called CredScan, where you can actually just scan your code against injection of keys and secrets. Today, these features come for free in open source when you're doing GitHub, where we scan automatically and we recognize all the different kind of keys and all the different kind of secrets with a lot of vendors that we work together with. And we can actually block the commits of those secrets inside of your repositories. If you're in a more enterprise environment, you can actually get a full overview of all the secrets that have been injected into your repositories. Of course, you want to mitigate that as much as possible. And therefore, we allow you to do the blocking of the commit before you actually push it back into the repo, making sure that no key can ever get inside of the repository. Yeah? If you do, however, you get a nice overview of what it is. And I can actually show you. You get a nice overview of what it is. Here we go. So there's a security thing inside of GitHub, and it has a code scanning, a secret scanning block. And if you inject some, and yeah, you can leave that. It's okay. It's safe. That database doesn't exist and that password doesn't exist. But if you were to inject it, you will actually get an alert, and you will actually see that on the dashboard, seeing where it ended up to. All right. However, it's not enough just for secrets and keys. You also need to make sure that you have IntelliSense inside of your IDE to make sure that the developer knows what kind of safe words or what kind of safe no, this is the correct one. What kind of now I'm confused. Sorry. Now, what kind of coding principles they should use inside of the SDKs? What are the most threat-safe ones, and so on and so on. For this, you need something which will help you in your IntelliSense. Now, today we have Copilot, which can actually also give you better security guidelines on how to build more secure code. You should use it as your advantage, because it will not only optimize current code and refactor that current code to a more secure state, but it will also, while typing, give you better leverage on the specifics, and I know why you're laughing. If you don't like Copilot and you want to do it in a different way, there's NuGet packages for .NET, but there's also DevSkim, for instance, that you can inject inside of your code as a package or next to your code and just scan your code after the fact. Also, tooling like Snyk this morning, where he showed you the command line, will actually help you in this thing. All right. But it doesn't stop at the IDE. You also need to make sure that you are aware of the CI/CD environment where you're working in. Having least privilege there, don't have full write access and read access on your total organization, but have just enough admin rights on the things that you need to do. If you only need to read because you're reading out a package, or whatever kind of system, or just a recommendation into some of the code parts, reading is more than enough. So you need to set those privileges as well. Now, this is Azure DevOps that you can see here, but any kind of system has these kind of permission settings, and you need to make sure that you set them right. Now, of course, faults can happen. This is exactly what happened at SolarWinds. Somebody got hold of the TeamCity because it was misconfigured. Not because, like the New York Times said, TeamCity is an obscure little application by an obscure little Russian company. Sorry, that doesn't do them credit. Period. Yeah? So you need to make sure that you set up this thing correctly. And for this, if you're doing Azure DevOps or even GitHub, we actually have a tool available which can scan your environment during build, and we will give you recommendations on, hey, look, you have too many administrators, you have way too much PAT tokens out there, all these little things that can actually give access to the system and do wrong are being identified here, and they show up in a nice dashboard report. This is a free tool that you can use. It doesn't cost you anything, and as you know, you have 5 users for free in Azure DevOps. Use this at your advantage, and you can have the full system secured and through the best practices. That brings me seamlessly to the secure building part. Now, the build part is the most important part, because this is where you're going to do statistical analysis testing, where you're going to do other kind of testing, where you're going to do infracode as testing, container testing, and so on and so on. And there's a lot of tools available. I mean, our systems like Azure DevOps, but GitLab, GitHub, you have a full plethora of choices that you can use there. I'm just going to highlight 2 out of them here, but my deck has more tools in there. But first of all, I'm going to talk to you about setting up the environment where you're going to deploy. What we all do today is do infrastructure as code, or at least everybody is doing that. Raise your hand if you don't. All right. People are actually admitting that they don't do. Fine by me. If you are doing this, make sure that you also test those, because in there you can actually do injections of things that you don't want to have, like setting up service principals in Azure, for instance, which gives you more admin rights, and actually people can use as a backdoor to get into your Azure subscription, and before you know it, they're using your expensive GPUs to do Bitcoin mining. Now, actually, we mitigate that, but there's still some things that you can do there. ARMTTK is one of those tools, but also Bicep now has a linter that can actually do this. So you can actually bypass the weaknesses that you've injected inside of your ARM templates or in your bicep files and actually see what is happening and report back on that. And use that eventually as a gating before deploying your code. Now, if you're doing bicep and you want to do a little bit more, there's also something called the DevOps CLI, which is a NuGet package that you can inject inside of either Azure DevOps, GitLab, GitHub, whatever, which is a CLI that can do both container scanning, which also does a little bit of SaaS scanning. It comes at a low cost, but the beauty about it is that it also reports back into a tool that I'm going to mention later, which is called Defender for DevOps in Azure Security. This tool has a lot of different tools inside. It talks with Trivy, it talks with third-party tools, and it gives you a Serif document, which is a standardized logging for security events. So this is something that you can use even from the command line on your local system just to test against certain things that you want to test against. Of course, you have the best tool of them all, GitHub Advanced Security. Sorry, Snake Guy. I already mentioned you a couple of times, so I give you credit. But GitHub Advanced Security has some advantages. It's completely integrated within your environment of GitHub and Azure DevOps if you buy the extension for that. And it does both this, on the same levels, the same things. Only in Azure DevOps, there's a little bit of a lag behind on certain capabilities of the secret scanning, but those are being worked on, right? But what we have here is in GitHub Advanced Security, you get a full security overview of all your repos if you're out of an organization, or in the single repo, giving you an overview of code quality issues, security issues injected into your code. Dependabot, where you can have dependency issues identified on both the levels of packages, but also the actions that you're using in Azure and GitHub Actions, for instance. We also do the scanning there and give you results back on saying, look, these actions here should be updated because of the lack of a certain npm package that is being injected here, and that needs to be updated, right? It doesn't have to stop there. You also need to make sure that your code itself, and for some reason my pen doesn't work anymore, your code needs to be signed at a certain point in time. And we have in preview still, and that has been announced already 2 years ago, something called Azure Code Signing. What you could do with Azure Code Signing is signing your code, signing your PowerShell scripts for those who do PowerShell or any other kind of scripting, and making sure that they can only be executed at the point where you allow it. Right? But you can also use this, for instance, to commit sign your Git pushes. So whatever repo pushes that you do, you can actually use this to commit it back inside of the repository, whether it's GitHub, plain Git, or whatever. So keep an eye out on this service, because this will actually give you a better, more secure way of handling your developer flow. And at the end of your build, you also want to make sure that at a certain point in time, you will become NIST 2.0 compliant. Those who never heard about NIST, it's a new directive by most of the larger federal governments, Europe, and all these things around it. And at a certain point in time, they will probably ask you this. If you do anything in supply chain, you will probably have to prove what you're doing there. And if you're a SaaS builder or a software developer that is actually impacted in the supply chain, you will probably be forced to prove that you're not using anything which is malicious and injecting that inside of the network that has an impact on the supply chain, right? And for this, you will need something called an SBOM, or software bill of material. Now, some antiviruses already capture these, and they block when an SBOM is not available for the software. So make sure that you are up to date with these principles, right? And it doesn't have to come at a cost, because we have a free tool for that you can inject inside of your CI/CD that will generate the SPDX format for you, listing all the things that are needed in the software bill of material. And then from there out, you can actually just validate that against the SPDX format, making sure that it is listed well, and even can distribute it if needed or requested. If you want to do it in a more easy way, GitHub also has that integrated inside of the dependency graph where you can just download it from a file when you look at dependency graph from the insides of your repositories. So from there, it's just a button that you can click, but it also has an API call, a graph API that you can call, and it will identify all the different elements that you've been using inside of your software bill of material. We even have a full set of modeling available for the software supply chain. This is something that you can download for free. It's a white paper that we wrote and that we brought back to the OpenSSF, yes, Open Software Supply Chain Framework, which identifies the best practices on that level. I may just fully go there. And it also gives you the best way of implementing all these different features and what are the things that are needed to make sure that you do a correct way of doing supply chain development. Right? So this is the full, let us call it the full CI/CD architecture that you need. I'll leave that for your reading, and that too. Yeah? And then the last phase is the deploy phase. And this is where you can actually start benefiting from the system administrators, where the ops guys get into the real knee-deep war zone, and where policies and role-based access control are also your friend as a developer. Why? If you don't have the correct role and the correct access control inside of your Azure subscription, you cannot deploy. That means that it's also a safe practice. Now, it might frustrate you, but it's for a better. Yeah? But if you want to make sure that you're doing it in a correct way, make sure that you set up a nice governance way of working together with the system operators, acting like a true DevOps culture, and making sure that you have templates, specs, and blueprints, making sure that there's policies defined that you can validate on both sides. And if you want to make sure that even for Kubernetes, you want to make sure that it also enters the Kubernetes, you can use something like OPA, not your average grandfather, but OPA, Open Policy Agent, which also works together with the Azure Policy Agents. And to top it off, you want to make sure that during the deployment, you also want to gate against the best practices. And this is where PS Rule steps in. Command line interface, it tests all the best practices with the policies that you have. It has a predefined set. And what it does here, it will identify it against the well-architected framework and where security is one of the pillars. And it will block your deployment because you didn't validate for certain things that you set as a policy. For instance, you're deploying a key vault and you didn't set a firewall on that thing. That thing will say, nope, you cannot do it, Mike. Sorry. Did a bad practice here. Go home. You're drunk. It's not the way to do it. Right? And then totally at the end, we're at the monitoring phase. And I know I'm 2 minutes over. Defender for Cloud will help you identify all these risks back in one central management point with correlations into the MITRE framework, with correlations into lateral movement, with correlations back to your code, with correlations back to your infrastructure, and bringing it all back in one single point of view. Defender for Cloud is a product that we announced a year and a half ago, where we actually are injecting with GitLab, where we can actually get information back from third-party tooling like Stick, like Sonar Cloud, for instance, and where we can actually say, look, you need to do the fixing on these things. You need to enable secret scanning. You need to make sure that in infrastructure as code testing, these bugs are being fixed. But it also will talk back to the container specs. Like, for instance, there's wrong references in that container. You should be updating those packages. These things will all come up and be shown in the Defender for Cloud main window. There's also live scanning of your environments. Open source tools at plethora. One of the better ones that you can use here is Zap, OWASP Zap, just a container that you can run. And if you want to have a real headache, this is a slide I always like a lot. This is our full end-to-end implementation of everything what we do at security point of view not only including developers, but also the end user, and where there's an impact of all the toolings that Microsoft has from an end-to-end security point of view, making sure that you are safe on all the different levels. You can download this slide, by the way. I always call this the headache slide because there's so much information on there. But it actually is a really important one that you need to take along with. But we show you that we care on every single level, whether it's developer, where it's the end user, where it's the system integrator, where it is the system manager, right? And with that, I say big bada boom, and thank you for your attention.